Okay, so in this session, I'm going to try to build off of a little bit what we did last week with contact conditions, and also add another concept that's called connections. And there are a few different connections you can do in SolidWorks simulation, but this week I'll probably only cover maybe one of them, which will be the spring contact. And most of the session what I plan to do is kind of do more of kind of a real life example of versus kind of the simple examples we're doing of kind of what you kind of expect to see and how to kind of use contacts, fixtures, and connections all kind of together in more of a real life example. So the example I'm going to try to do today is going to be kind of a spring. This will kind of also help with the fluid viscous dampers project. So it'll be kind of a spring compressed between two different plates and kind of how to set up a simulation like that. It's almost like a kind of like a shock absorber type structure. So part of this I'm going to spend on modeling. The other part I'm going to obviously spend in simulation. So it'll kind of be a kind of a mixed session today between modeling and simulation. Okay, so let's get started here. So I'm just going to start, I'm going to do a part here. I'll show probably later if I have time how to convert a multi-body part into an assembly. What I mean by multi-body is kind of how I was doing last week. I'm going to have several bodies within one part that I can run a simulation on. Very similar to how you have separate components in an assembly. So there are advantages and disadvantages of both. Obviously, with multi-body parts, you're not going to really be able to move stuff around like you can in an assembly and get motion and stuff like that. But it is actually fairly easy to convert a part to an assembly with multiple bodies. So if I have some time, I'll show that later as well. So I'm going to start out with just a normal inch part here. And I'm going to kind of start building this, structure. And again, I'll try to go through along here. If any of you have any questions or anything, just feel free, and I'll try to stop in different places and ask for questions. So I'm going to start modeling here. So I'm going to start off on the top plane, and it's going to probably make a little bit more sense once you start seeing everything come together. I'm going to start off here. I'm just going to draw a couple circles on the top plane here. I'm actually going to draw three, one inside the other. And I'm going to go ahead and dimension these. I'm going to dimension the outer one as like 4 inches. I'm going to dimension the inner one as, let's make it 3/4 of an inch. And then for this one, I'm actually just do a dimension in between. So I'm going to kind of do like an offset dimension. And let's call it maybe 0.375, so 3/8 of an inch. Okay, so that sketch is fully defined now. I've got 3 contours. I've got 1, 2, and 3, and I'm going to use that to actually make 3 different features to kind of start modeling this. So if I kind of rotate this around, and so let's go to features. The first one I'm going to kind of do, I'm just going to do an extrude here, and I actually want to extrude. I'm using my selected contours here. I want to extrude all 3 contours, and I want to extrude this down in this case. I'm going to extrude it down, and I'm going to give it like I'm going to give it an extrude depth of maybe, let's say 0.25. Maybe I'll make it a little thicker. Let's make it, maybe 0.375. Yeah, let's make it 3/8. Okay, so we have that. So I'm going to go ahead and extrude this first. That's the first one. So you just kind of have a disc. I'm going to go ahead and save this part here real quick as well. And let's just go and save this. And let's call this spring example. So let's spring example. Okay, so we have that. Then what I'm going to do is I'm going to use the same sketch. So this is a very powerful tool in SolidWorks as well. The selected contours option within extrudes or revolves or any type of feature. A lot of features have this. But predominantly you see it used a lot in extrudes where you have several contours that you may want to just extrude different depths or different shapes. So in this case, I'm going to click on the sketch again. And I'm going to go to features, I'm going to go to extrude, and I can use the same sketch to actually create a separate extrude, which is really, really nice. And then for my selected contours again, by default, it's going to select the entire sketch, which I really don't want to. I'm just going to clear that, right click, clear selections. And what I want to do here is I want to just select just this outer portion here. In this case, I'm going to start extruding up. I really don't want it extruding up. So I'm going to flip the direction down. So what I'm trying to do here is I'm trying to give it a little lip kind of around the outside where this spring is going to kind of sit, kind of like a shock absorber on a car. So I'm going to do this. And then what I'm going to do is I could do this a couple different ways. I'm extruding from this top surface here. So I could either extrude down and just up the extrude distance, or another way, if I want to have a specific distance from this bottom face here, I can switch this from dialog here. Instead of sketching from the sketch plane, I can sketch from a surface face or plane. I can select this bottom face. And now I kind of have, now it's extruding actually from here, although the sketch is actually sketched up on this plane here. And I can maybe increase this a little bit, make it 0.5 inches or something, just to give it a little bit more room. So we'll do that and we'll go ahead and hit accept. Let's go and save again real quick. And so now what we have is we have this, so the spring is going to sit in there, and then what I'm going to do is I want a rod actually coming down here, and then the spring is going to be going between this portion here and another portion somewhere down here. So I'm going to use that same sketch again since I sketched that little circle in the middle. I'm going to use that for the rod. Again, both of these features have the same exact sketch, so either you can edit or not edit, but you can create a new feature off of either one of these sketches because they're exactly the same sketch, although they're listed twice. So I'll go here, I'll do another extrude, very similar. I'll clear this out and I'll go and select that inner portion. Again, let's go and flip the dimension here and I'll do the same thing. Let's do a from surface face or plane, go there and let's give this like a depth of maybe like 12 inches. So we'll do something like that, kind of like a nice long rod. Again, you can always adjust any of this. So we'll do something like this. Okay, so we have this. Now what I want to do is I actually want to create kind of a platform down here. So this is going to be kind of pressing against a platform. And there's going to be kind of a spring in the middle. And the spring, I'm not going to end up modeling. I'm going to kind of get into simulation where you can use the spring connection. So instead of having to model a spring and doing a rather complex contact problem, you can just actually have SolidWorks simulation consider there's a spring there without actually physically modeling it, which is a really, really nice feature. So the next thing I'll do is I'm going to create a new plane. I want to create a plane somewhere down here to be able to create this platform. So I'm going to do reference geometry plane. A quick way to do this, if I don't want to have to go through reference geometry plane, very quick way to do this is you can go to the top plane or whatever plane you want to do an offset plane of. Click on the top plane and you'll see these little kind of little balls around the outside of the plane. I can hold on my control key and then click and drag on any of those balls, and that will actually give me a new plane, with an offset distance, and then I can specify this distance right here. And in this case, let's see, yeah, maybe 8 inches is probably about good, maybe. Yeah, so we'll do like 8 inches. So let's do that, and I'll go ahead and hit accept. Okay, so we have this. Then what I'll do is I'm going to go and sketch on this plane, and I'm just going to sketch just a center point rectangle. It's actually just going to be a square. So I'm going to go and sketch here. I'm just going to place this out here. And I'm sketching, as you can see, I'm actually sketching down here, although it looks like I'm sketching up here. But I'm sketching on that new plane I created. Hit Control 8 to go normal 2. And since it's going to be a square, I'm just going to grab both of these lines right here and make them equal. And I'll give this a dimension of, let's do maybe 8 by 8 inches. Obviously, since it's equal, I only need to put one dimension. It's going to automatically dimension this one as 8 as well, based on that equal relationship. So we have that. Now what I'll do is also, I don't want this rod. I need to have a hole in this platform for this rod to go through. So what I'm going to do here is I'm going to do another neat tool in SolidWorks. I'm going to kind of sketch a little bit in 3D here. This is not a 3D sketch. This is just a 2D sketch, but I can kind of rotate around in 3D if I want to select different entities to either convert or offset. So I want to use an offset entities, and because I want to make a little hole here, but I want the hole to be bigger than the rod. And I'll explain why that's important when I get into the simulation part or maybe a little later. So I'm going to select this edge right here with the offset entities. And I'm going to kind of look here. And yeah, 0.1 inches, that's probably, let's do maybe a 0.05. I want to have a little bit of clearance, but I still want to have a hole here. I don't want it to be intersecting. So I'll do this. I'll go ahead and hit accept. And now if I go back up here, I have technically, again, 2 contours again. I have this contour for the rectangle or the square in this case, and I have this little part in the middle. So what I'll do here is I'm actually going to end up extruding this whole portion minus this little contour I have in the middle. Again, you could also use this as a separate extrude cut to do it after, which in practice is usually a little bit better if you're trying to get a model that you can either suppress the hole, trying to be able to modify the hole a little easier. Sometimes it's better to have separate features. In this case, I'm using just doing one feature here and just extruding it without this middle portion, just for the sake of time. It's a bit quicker to do it this way. So we have this. Let's go to extrude here, and well, let's go and flip the direction. And obviously, do not want to make this 12 inches. Maybe let's make it like half an inch, so 0.5. And I want to go to selected contours here, and I want to make sure, again, I'm only selecting this portion and not this portion in the middle. And so that looks about right, and I'll go ahead and accept. Okay, so let's go and save real quick. So we have something like that. I can go and hide this plane at this point now because I really don't need to see it anymore. So now what I can do is I want to make almost kind of a mirror image of this portion here on the bottom. Again, I could try to do a mirror, but in this case, it's a little bit easier just to use, I'm going to use one of these sketches from up here to actually create a feature here. So what I'm going to do here is go to that same sketch again. And although I'm going to do that very similar, do it from sketch or from surface face or plane instead of doing from the sketch plane. So what I'm going to do is I'm going to grab this sketch. I'm going to go to features. And so let's go to features here. Let's go to extrude. And in this case, again, for selected contours, I'm going to clear these. And I only really want this rim right now. But again, I don't want to extrude from up here. I want to actually extrude from down here. So what I'm going to do is I'm going to go to from again, go to surface face or plane, and then extrude from here. And I'm going to make it a 0.5. If you recall, 0.5 is the same distance I did from this face down to this face. So why not do it at the bottom? I'll use the platform as the backing of this kind of ring that I'm creating. So I'll do that, and I'll go ahead and hit accept. Okay. And if you notice now, we actually have two solid bodies. This was actually created from before, even before this feature, I had two solid bodies. So this is what classifies a part as a multi-body part. You have a part that has multiple bodies in it. So I have this portion here. I have this portion here. The reason why these were created as separate bodies is they're actually not touching. If you know there's a gap there. So to have one body in SolidWorks with if you're having separate features, they have to be actually touching to be able to merge them into one body. And also when I roll forward here, this is obviously getting merged to this body. Again, I think I might have talked about this in a previous session, but there's a checkbox here that's called merge result. If I uncheck merge results in this case, again, this would work for up here as well, is now I'll have three bodies. I'll have this body still, then I'll have kind of the base, and then I'll have this ring as well. All as three separate bodies. In this case, though, I want the ring to actually be merged to the kind of to the base here. So I really don't want to uncheck the merge result, but there are times where you want to have them as separate bodies, even if they're touching. So that's kind of how you can do it if you need to separate them out. Again, there's also a tool that's called, there's also a command that's called a split command that you can split it after the fact as well, which is useful in some different situations if it's not as easy as just not merging it when you're extruding or doing a feature like that. But I'm gonna go and do merge result here and do that. So I want two solid bodies. So now I have this portion here, and I have the base with this portion here. Okay, so what I'm gonna do here is on this rod, so you can kind of see what I'm gonna do. On this simulation, there's gonna be a spring that's gonna kind of go in between here, kind of like a shock absorber on a car, like I said earlier. And I'm gonna apply a force on this face right here, pulling it down. So with that, I don't want to have this sharp edge right here, because again, I don't want to have a stress concentration forming here. So I'm gonna go ahead and put a fillet on that face. So let's go here, let's go fillet. One thing when you are working with a multi-body part, you cannot do a fillet on multiple bodies. So you'll have to, if I wanted to put a fillet, let's say if I put a fillet here, well, up that, maybe let's do 1/4 inch. So I can do a fillet here, I could fillet this edge, I could fillet any edge that's on this body, but I cannot fillet an edge on this body and then go to, let's say, this body here and try to put a fillet. What it'll do is it'll give you an error or give you a little message saying edges from multiple bodies cannot be filleted in a single feature. So if I wanted to put some fillets here or something, I would have to do that as a separate feature. Just something to keep in mind when you're dealing with multi-bodies. In this case, though, I really don't need to fillet anything else. I could technically try to put a fillet here, but again, the bulk of the force from the spring is going to end up being in this region here. So I don't really need to worry about that too much. So I'll do that, and I'll go ahead and hit accept. So now I have this fillet here, so that'll relieve that stress concentration there, which is good. Okay. So the next thing I want to do is I want to actually create, because the spring, when I have a spring, the spring is not going all the way to the middle. It's going to only be kind of in kind of a region around here. So obviously the spring is hollow in the middle. So it's going to be applying a force to kind of a region kind of in this area here. So I'm going to go ahead and try to do, I think I showed the split line again a couple sessions ago. So I'm going to kind of split that out with a split line. kind of showing how to do that. And so I have that actual thing when I get into simulation where I can apply my spring constraint. So what I'm going to do here is I'm going to sketch. Again, I can sketch now either here or I can sketch here. It doesn't really matter. I can just sketch here for this one. I'm going to sketch. Again, I'll rotate this a little bit so I can see this edge. So I'm going to grab this edge here, and I'm going to do an offset entities. In this case, I want to reverse the offset. I want it offsetting actually on the inside, not the outside. So go ahead and hit reverse. And then let's make it, let's see what a quarter looks like. Yeah, let's make it about a quarter of an inch. So the spring, let's say that's the thickness of the spring. Again, this is going to highly depend on what type of spring you have, how thick the coil diameter is and everything. But so obviously you're going to want to measure the spring and figure out obviously the outside diameter, how big these need to be, and also the inside diameter, which is going to be the outside diameter plus the diameter of the actual coil or the wire diameter of the spring. So I'll do this. So let's do a quarter inch there. And then what I'm going to do here is I'm going to use the split line command, which is under features, curves, split line. I'm going to use the projection method. I think I talked about this a little bit a couple sessions ago. I'm going to use the projection method, and I'm going to use the current sketch to project, and I'm going to actually project on both of these faces here. I'm going to do that, and I'm going to hit accept. So what this will do is now if you notice, this is actually split both of these faces into two separate faces now. And that's going to come in handy when I actually want to create my spring connector between these two. So we've got that and that also there. Okay, let's go and save. Any questions so far on any of the modeling or anything I've done so far? Okay, so that's pretty much about it for the modeling. So now we can actually kind of jump in SolidWorks simulation here and kind of start setting up this analysis. So this is fairly a real life kind of analysis. This is something that you probably would see in real life if you're working on a car, if you're doing some sort of spring application. This might be something you might want to analyze versus some other ones, are a little bit, some of the previous ones we were doing. They're great for kind of learning the basics of simulation, but they're maybe not 100% realistic or like actual examples you might see in real life. This is a lot closer to an actual example. So what I'll do here is let's go and jump over into simulation. So we'll jump into the simulation tab. We'll do a new study. And then what we'll do, I'll just leave it a static one. Let that go and create. So we have that. Then what I'll do is one thing here, so we're gonna have to go and apply our materials. In this case, I'm going to, let's go under here. Again, when you have a multi-body part, or if you're dealing with an assembly, it'll be very similar to this. Again, if I have some time later, I'll probably convert this over to an assembly so you can kind of see what an assembly would look like. Again, the simulation will look very, very similar to this, except instead of multiple bodies, you have multiple components or parts, but it'll look very similar. So in this case, what I need to do here is these are already set as plain carbon steel. I can kind of see that from over here. And that's fine. I'm not really concerned with the material, but if it's not, you can also modify very similar to how I did last week. When we go to apply to material, you can apply materials to separate bodies, different materials even. So if I want to do kind of a composite structure like I did last week with those kind of two beams, like cantilever beam with two different materials, one on top of another, that's a way that you can do it. And you can always watch the recording from last week where I kind of went through that. So we've got that. So now our material is done. For our connections, one thing, let's see here. So for connections, technically, so we'll go under component interaction, or sorry, not connections, interactions or contacts. So our global interaction, it's going to be bonded. In this case, in this specific study, it really doesn't matter if I do bonded or contact. Obviously, the bonded, and this is why I actually wanted to have a slightly bigger hole here, because if I had a bonded global interaction, and this hole was on size, meaning it's the same size, if this rod is 3/4 of an inch, if the hole was also 3/4 of an inch, what would end up happening is since they touch each other, this bonded interaction would automatically pretty much fuse them together, which is obviously not what I want in this study. I want this rod to be able to move up and down. So bonded is not what I'm going for. So again, I could switch this to contact, but again, there's no real contact in this case. If I had a actual physical spring that I modeled, then yeah, I'd either want to do a global contact interaction, or I want to go maybe at the local level or component level and kind of think is it local? Yeah, either a component interaction or a local interaction between the different pieces, between the spring and obviously this upper portion and the base. But in this case, I don't really need to do that. This is where the kind of spring, and again, one thing also with the spring, when you're using connections in SolidWorks, the connections pretty much are just a way to kind of simplify geometry. So it's like if I have this complex spring here, or it's just even a regular helical spring, first I have to model it, then I have to kind of see how it's going to go, and then it's going to be a contact problem. And again, I think I talked about this last week, where anytime you're dealing with contacts, especially when you're dealing with like a non-penetration or what's now called just a contact constraint or contact interaction, I think is what it's called. Let me, if I do component, let's just make sure. Yeah, contact is called contact. Um, it's going to make the study run quite a bit longer because it's got to compute all of these contacts. So in this case, I really don't need. I don't. I'm not really concerned really about the spring where it's actually interacting. Now, if I was really concerned about kind of how the spring was interacting with this face here, then yeah, I would probably want to model the spring, and I would actually want to go in and do a contact constraint. But in this case, I'm really concerned more about kind of the stress in the rod here, just to see if the rod will actually, kind of see what the stress is and everything. So it's the spring connection is a good way to kind of simplify our analysis. You're not going to get extremely accurate results in this face. So if you're really interested in how the spring is interacting with the faces, then this is not what you want to do. You want to actually just model the spring and then actually do a regular, contact interaction. But in this case, if you're more concerned with kind of the stress in the spring, or sorry, not the stress in the spring, the stress in the rod, maybe the stress up here, if you're trying to see if there's any stress concentrations there, then this is perfectly fine. And it's a way to kind of simplify your study quite a bit. So let's go and start setting up this study real quick. So component interactions, I really don't need to do much with this. What I'm going to do is let's go and start our fixtures, and I'll do our loads, and then I'll actually come back and do the connections, which will be under, which is under connections, which is also under interactions. So they're kind of all under the same category. So let's go to fixtures here. I'm going to start with just with a fixed geometry, and I'm just going to fix the bottom face of this base. So kind of pretend like it's sitting maybe on a table or something, and maybe the table also has a hole down the middle, so this rod can go up and down. So I'll go and do a fixed geometry right there. And so we'll do that, and we'll go ahead and hit accept. Let's go save one more time. So we've got a fixed constraint there. Another constraint, I think I talked about this when I was talking about different fixtures. Obviously, I want to make sure that this rod and this whole body here stays pretty much concentric on this hole. I don't want it kind of wobbling back and forth or anything. So I want to make sure that it stays pretty much linear up and down. I don't want any kind of movement in any other direction. So I want to constrain that as well. So I want to go down here to our fixed geometry. And again, I can either go to fixed geometry, I can go to kind of an advanced fixture, either way. So I can go to the advanced fixtures here. And I'm going to use the on-cylindrical faces fixture. Again, I did talk about this, I think maybe in the second session. So in this case, I'm going to select this face right here. And what I'm going to tell SolidWorks simulation is I do not want this face here to move in the radial direction, which is right here. So meaning I don't want it to move, I don't want it to deform. So what this is pretty much in essence doing, it's kind of almost saying like a concentric mate in an assembly where it can't move this way, it can't go anywhere, but it can still move up and down. It can also spin around its axis, but I'm not applying any torque or anything, so it's not really going to matter. But the spinning, I could again, if I wanted to, I could constrain the circumferential element of this as well, but there's really no need. So I'll leave it as just the radial. And again, when I leave this as 0 millimeters, that's saying 0 displacement. It's saying pretty much fixing it in that direction, which is what I want. So we'll do here, again, the reverse direction in this case is not going to do anything because 0 in one direction is the same as 0 in the other direction. So we'll do this and we'll go ahead and hit accept. Okay. So now we have our two fixtures, and that should be all the fixtures we really need for this part, or this study rather. So now if we I'll take a pause for a second. First, does anybody have any questions so far? Okay. So I'll kind of pause here for a second to kind of talk about kind of the fixtures and kind of looking at it and figure out what we actually constrain and how it's really still a part, but how kind of this component or this kind of assembly of bodies is going to actually perform. or what is still able to move. So obviously this fixed constraint constrains this entire bottom portion here. So the entire base is fixed because obviously this is connected to this. When you have the fixed here, that entire body is fixed. Obviously this one face is fixed, but obviously the rest of the body can deform. I actually should say, I should probably clarify that a little bit more. But so by this face being fixed, the rest of the body can still deform, but it's not going to be able to just fly off somewhere into space because this is actually pretty much grounding or just holding it. So you're going to still be able to see stress. You're going to still be able to see stuff, except obviously on this back face because it's fixed. And if you see any stress there, it's not going to be very accurate because of that fixed constraint. Then this, what is it called? This radial constraint here is pretty much like I said earlier. It's just allowing this. It cannot move in the radial direction. It can still spin if it wants to, but it's going to allow it still to move up and down, which is kind of what I'm looking for here. So then the next thing I want to do is, so now we kind of understand the behavior of the model we have. What I want to do now is actually add this connection in here. So I'm going to go up to here. There's a couple different ways of doing this. You can either go to connections, or you can go up to the connections, not connections advisor. Let's close this. So not connections advisor. You can go under connections. You can go down here to where is spring. You can go to spring here, or you can right click on connections and then do where is it? Spring, the first one. Okay. So this is what will kind of appear when you have that spring, when you're looking at that spring connector. So the first kind of thing you want to look at, there's three different main options right here. You have compression, compression extension spring, so a spring that can either compress or extend. You have just compression only springs, and you have tension or extension only springs. In this case, this is a compression only spring, which most shock absorbers and stuff like that are. It's obviously only compressing. I don't really need any extensions, so I can just set that to compression only. So we have this. There are also some, you can also specify the different, let's say you went into the wrong connector and you wanted to change it, you could go into a different connector type from here as well. Okay, so we have that. Under here, in this case, I do have flat parallel faces. I obviously have this face and this face. So I'll keep that option. Again, if you have different kind of faces you're looking at, you can specify different kind of different conditions here. So the next thing for kind of defining this, I'm going to go into these two different boxes here, or these two different dialogues, and I want to select one face in each dialogue. So in this case, I'll select this face in that dialogue, and I'll go into this dialogue here, and I will specify that face. And you kind of see SolidWorks simulation gives you the kind of little spring symbol. So in essence, what it's doing is it's pretty much creating a spring. You don't actually see it, but it's pretending like a spring is contacting between these two faces. So if you had a kind of a big spring kind of going around like that, that's pretty much what it's simulating. So it's a really nice and easy way. Again, like I was saying earlier, if you're looking for stress or stuff in this region, it's not going to be extremely accurate. You would want to do that with a contact condition. But in this case, where I'm looking more for the raw geometry, this will work perfectly fine. So this is really, really simple to set up. So the next thing is you got a couple of options that are here. Again, you can have the unit system. And you have an option here for distributed or total. So distributed, I'll start with total. So total is pretty much you're specifying the spring constant. So obviously newtons per meter. Anybody who's taken vibrations should be very familiar with kind of these kind of units for spring constant. A distributed is pretty much, it's like a spring constant per unit area. So depending on the area of the faces here, it'll actually, so if you put, let's say, I don't know, 1,000 newtons per meter squared, if this area happens to be 1 meter squared, it'll have a spring constant of 1,000 newtons per meter. But in this case, I'm going to use total. It's quite a bit simpler. So I'll do total here. There's also two different options here. You have either the normal stiffness, and you also have, I believe it's the shear. You have the tangential stiffness, which is almost like a shear stiffness, like how much it's going to shear in this direction. But again, since I already restrained the radial direction here, it cannot move in this direction. Again, since I restrained this one radially, and this is connected to the rod, these are technically all constrained in the radial direction. Obviously, just by the geometry being there, obviously, because when you constrain these elements are obviously going to transfer force to the inner ones, which is going to transfer down. So we have that. So I'm not going to really worry about the kind of the shear stiffness or the tangential stiffness, but if you need to, you can obviously specify something in this box. So in this case right here, I'm going to go here and I'm going to say, let's say this spring has, let's say 500. let's see, let's make it like 500 newtons per meter. Again, we're gonna have to see how this actually works once we run the simulation. This may be too much, so we might have to modify it because I'm just kind of coming up with these values off the top of my head. So we have that. And another thing we can also do is we can also specify a preload. So maybe this spring is already under some preload, so you've already have some load on it. Like a lot of times also for shock absorbers, if you've ever seen a shock absorber for a car, you'll see there's usually a nut or a bolt on top that you can actually turn to actually apply a preload. They usually come preloaded, but if you need to modify it for some reason, you can kind of modify that. But most stuff will be already preloaded. It's not just gonna be a loose spring sitting in there. But in this case, I'm just going to say it's already, it's already loaded. It's just there's zero preload on it, so it's literally this is the undeformed spring, and then when we start applying our force to the bottom, that's going to end up compressing the spring. So we have that. So I'm not going to put any preload here. This is pretty much all we have to do for the spring constraint. Again, if you want to switch units, this kind of goes for anything in SolidWorks simulation. There's always the option here just to switch between SI and like English IPS or metric or anything else. So we have that. And now what I'll do, I'll just go ahead and accept. Okay. So we have this now. So we obviously have our spring connector. Again, it looks like it's just on either one of these faces, but really in essence, what it's doing is it's creating a spring, like almost like a virtual spring between here and here. Again, we just can't see it because it really doesn't care what's in the middle because it's not analyzing anything in the spring. Again, another reason where you would not want to use this if you're trying to actually figure out the stress in the spring, or the kind of the deflection maybe well, obviously the deflection you're going to know based on how far this is coming down. But if you want to see if there's any stress in the spring, what that is, then you probably want to go in and actually model the spring and actually analyze that. But again, that's a much more complicated problem because then what you're going to end up having to do is you need to know the exact material of the spring to know how much is going to deflect and everything. In this case, you really just need to know, like the stiffness here. We don't really care what material it is and stuff like that. Okay, so we have this. Now let's go and do a load. Again, I'm kind of skipping around here. You can really do this in any order. Like I said, it's usually good to kind of just come from the top down to the bottom, but anything above mesh can really be changed at any time. It doesn't really matter what you want to do. It just depends. You can kind of do it however you like. But especially if you're kind of new to simulation, it's always good just to kind of follow the bouncing ball and just kind of come down the list. And obviously under connectors, it created this new folder now. And now we have that spring connector here. And again, you can do this many times as well. Maybe you have 4 springs that you're trying to analyze in different areas. You don't just have to do one of these. Just like fixtures, you can put as many of these as you want. So okay, so next let's do an external load. So let's right click here and let's just do a force. And so for the force, I'm gonna go, let's put a force here. Let's reverse the direction. And let's say it's 1,000 Newton load here. And see, so let's do that and kind of see what we're dealing with. Let's go and save one more time. Okay, so we have this. Now, at this point, our study is pretty much set up. There's really nothing we need to do. All we need to do now is actually mesh and then run it. And we'll kind of see what our results look like. Before I start running it, any questions or anything so far? Okay, so next, let's go to our mesh, and then let's do create mesh. Again, I could technically even do a mesh and run in this case, because I really am not caring about the mesh. I'm just more trying to kind of show you guys how to set up these studies and how they look. But let's just go and create a mesh. Why not? So let's go through here and we can leave it kind of at the default. Let's just go ahead and accept. Let's see where our mesh is. Again, it's going to mesh these components separately. There's only one element on the corner here. But again, it's not a big deal. Most everything has 2 elements across. And I'm not really concerned too much with the corners here anyway. There's not going to be hardly any stress there. So we have that. That's what our mesh looks like. Again, here we've got, looks like 3 elements across. That's good. Okay. That's our mesh. Now we can go ahead and actually run our study. And let's go and run this. And it's going to give us kind of not an error necessarily. I don't know. I'm not sure if you actually can see this. because the way I'm sharing this. But if you can't see this one, I'll kind of read out what it says. So it's going to say excessive displacements were calculated in this model. If your system is properly restrained, consider using the large displacement option to improve accuracy of the calculations. And then it goes on, otherwise, there's a bunch of other stuff. So the reason I'm getting this message is what's happening here is since this whole thing is actually moving down, and it's moving down by a sizable amount. Again, we haven't had the results yet or seen the results to see how far it's moving down. But so it's saying this is displacing quite a bit. So do you want to use the large displacement model? And I think I talked about this in one of the previous sections or sessions, is where you want to, large displacement is when you have a thing that's actually deforming by that amount. So if you have like a part, maybe it's like a beam that's like this, and it's going from this to that, where it's like really deflecting a lot, then yeah, you probably want to use the excessive displacement model or excessive displacement option. In this case, though, nothing is really the deflection that we're actually seeing is actually not even deflection. This piece is just moving down because of the spring. The spring is trying to resist it. It's moving down. Nothing's really deforming. Obviously, the rod is deflecting, but the rod is deflecting nowhere close to what the spring deflection and what this portion here is actually moving down, or kind of the deflection it's moving down by. So in this case, I don't need to run a large displacement analysis here. So there are cases where you may get that error and just look at it and say, no, I actually don't want a large displacement analysis. This one is fine. So I'll just hit no. And it's a fairly quick study. Let's see here. Look at our stress. Let's go here and edit our chart options. Let's put this in megapascals, and let's do floating. Let's do that. There's megapascals. And let's see. Let's do the same for displacement. Okay. Let's go floating there as well. Okay. So we have that. So again, just looking at our stress plot here, we've got a super high factor of safety. Factor of safety of like, if it was 10, it would be 22, but it's not. So we got a really, really high factor of safety. So this is really over designed. So we can make it a lot smaller. But again, just for kind of for demonstration's sake, this is a really good example. So obviously, this is kind of what we're expecting. We're expecting that high stress concentration there. Again, especially when you're dealing with stuff like this that's moving and you're dealing with some connectors and stuff like that, it's always good, again, like I said, to go and animate this. Let's go and pause and let's stop. Let's make this like let's make it 100 frames or something. So it's a really smooth animation, and kind of speed that up a little bit. So that is kind of what we're looking at. You can kind of see how the stress is kind of developing. And obviously, because of the spring, you're going to end up, the more it compresses, the more force is going to be applied to here with the spring. So indirectly, we're applying a load here, but based on that connector, that spring connector is actually applying a force to both here and over here. Again, you'll see a little bit of stress kind of forming there, but again, I would not put any weight onto kind of what stress you're getting from there. Again, it's just a connector. It's not really meant to give you super high, results on that area. It's meant to just kind of connect them together if you're trying to analyze other areas. So you can see the stress there. You can also see the stress kind of forming on the middle portion here. So this is kind of really cool simulation, I think, to kind of do. So we have that. So now let's look at our displacement. Let's see. We've got millimeters, so let's see. I don't know why our millimeters are super high. Let's go to here real quick and see, because it should not be. I don't think it should be displacing that far. Displacement. So let's see. Let's go to this. Let's see, because I did add an extra displacement plot here. So let's go and let's go to edit definition here, and let's go to wrong one. Let's go to where's my? It's not gonna give me an option for. Well, let's just see what that looks like. Oh, that's just doing that. Okay. So one thing, this is something to obviously look for is when we're seeing this and we're seeing this really, um, really high displacement here. And let's see, we can even switch this to inches just to see. Actually, that's not what I wanted. Let's do it at the definition. Let's go and switch this to inches to kind of see what's going on here. Let's go here. Yeah, so there's no way that this is deflecting 78 inches. So that's something to kind of look at and figure out why is it doing that. Again, another thing we can do is let's go back to the model here and just make sure that I didn't type something in completely wrong. Let's go to here, let's go to here, and let's just do a measure. And that's 6.625 inches. So yeah, this should not be displacing that far. Let's see here. So let's see if we go back to our static here. Yeah, so again, that should not be, let's make sure it's not giving it to us in scientific notation. No, it's not. So in this case, the displacement is not going to be apparently accurate. So let's try, let me see if I can try to rerun this study real quick just to see if it's going to give me a different result here. I don't want to do large displacements. Maybe did it. Yeah, still give me a really high displacement. So if you see something like that, then you kind of have to kind of troubleshoot. We are getting the correct motion though. And if you notice here, the deformation scale is, oh, wait a second, deformation scale is, oh, maybe we are getting the correct. So let me do something here real quick. Yeah, so one thing you also want to look at is deformed results. If I look at the deformed results, deformation scale is this. So if I go to the deformed result and let's go to our displacement here, let's go and edit the definition and let's go to, instead of automatic, let's do true scale. And obviously, okay, so that one flying through the thing. So that's obviously, I put way too much force. So yeah, this is not obviously accurate. So let's go back and kind of modify that a little bit. So that's kind of the troubleshooting you want to kind of do, kind of just kind of pick those values kind of off the top of my head. And again, when you're doing that, those values don't always work out too well. So let's go to our force here and let's give it, I don't know, let's give it like 50 newtons. Just kind of see what that looks like. Again, I don't need to modify the mesh or anything. I just changed the force. So let's just do this and let's go and run this study again. And again, I don't know if you guys can see that. Yeah, you're probably not seeing that message. Again, the large displacement hit no. Okay, so we go here. Okay, now we're down about 4 inches. Now I can switch this back to millimeters. I keep hitting the wrong button here. Chart options. Actually, not chart options. Let's go here. Let's switch back to millimeters. Okay. Okay, so now we have about 100 millimeters, about a little under 4 inches displacement. So that looks really good. So now, and again, look at our deformation scale is 1 to 1. So this is the actual, what it would actually look like if you put that load. Again, what you can also do is go back to here. Let's go here, edit definition, and let's do automatic. And then it'll kind of automatically calculate it. So it's doing something like that, 0.314. But usually, this is a personal preference for me. I usually like having the deformation. I usually like having it, if it's a deformed thing, like maybe 20 to 1 or something, where if it's displacing a tiny, tiny little amount, I don't need to see, I want to see it on a bigger scale. If it's deforming like a lot, I don't really necessarily want to see it smaller. So in this case, I will actually keep it at a true scale or a 1 to 1. Just because I want to actually see what it's really doing. Okay, so we have that. Let's look at our stress now. Our stress is probably really, let's see here. Let's double click there. Yeah, our stress is like really, really low now. But I'm hoping you all kind of get the idea of kind of how to set that up. So it's kind of a little bit of, so you're using connections, using, again, we're using that global content of bonded, but again, that bonded is really not doing much in this case. And type of stuff like that. Any questions so far? Okay. So let's see. So we've got that. So that's obviously the spring connection. I'm trying to think if what else I can do on this study. Um, Maybe I'll, for the last little bit here, let's just show, so that's pretty much kind of the example I want to do today, but what I'll do is I'll show you how to, if you ever have a multi-body part and you want to actually bring it into an assembly, I'll kind of show you how to kind of export that and stuff like that. So let's go over to the model again, and I'll probably show you also how to set it up in assembly quickly, but it's going to be very, very similar to this. Um, okay, so we have this, let's go here. So we've got those two bodies. And there's a couple different ways of saving these out. One of the quickest ways, just go into your solid bodies folder. You can either, so right click there and then do save bodies. And what you'll do here is you'll just select, let's see this. It'll give you a thing to say where you want it to save. You can just save it like, under downloads or something. Let's do this. I'm just gonna kind of rename these. As we're renaming those. Okay. So kind of save those out. So it's like both of those. You can either give it a name or you can have it name itself. But so then what I'll do here is you can also have this option to create an assembly. So this is a really nice feature. So you can just also browse. Again, it'll bring up your file explorer. You're probably not, I guess you are seeing that. So you go to your file explorer here and just go ahead and save it. We'll just call this spring example for an assembly, and I'll just go and save that there. Okay, so we have that. The next thing we can do is obviously do our different templates here. So if you have templates for the assembly and stuff, you probably want to do this and just browse. Again, for the parts, because this is save these bodies as separate parts as well, and then create an assembly with everything together. So I have some default templates here. So if you have any templates, this is the time to kind of use them again for the assembly. It automatically kind of pick those up, but let's do that anyway just to make sure. You can also specify an origin location. Where do you want the origin in the assembly? But it doesn't, in my case, it really doesn't matter too much. So now I'm going to do this. I'm going to go ahead and just hit the green check. So it's going to go ahead and kind of save some stuff out here. Might give you this. I'll just say no. We don't really need to change the units or anything. So it'll kind of save these parts. Just to rebuild and save, that's fine. So, okay, now if we kind of go to our window now, we've got a couple different things. We've got our spring example. That is the part that we did. Again, let me know if you all can't see that. Let's see here. If we go to window. So we'll go to window here. So you got a spring example, which is the original part we had. Then you have the split line 1, which is that first body. So kind of almost like call it like the plunger. And then we have kind of the base. And again, you could name these, give them more descriptive names as well. So we have that. Then what we have here as well is we have that, we have the assembly. And so let's go and switch over to the assembly here real quick. So we can kind of see what we're dealing with. So now it looks very, very similar to the part, but now we have separate components here now. So it's a nice, quick way to actually convert a multi-body part into assembly, because sometimes it's quicker if you were dealing with spacing or something. Like, obviously, I know that I want these to be the same diameter. It's quick to kind of do those in the part environment and then be able to convert them over into assembly to actually be able to kind of have that motion that you get in an assembly. So now, obviously in assembly, if I try to click and drag here, both of these come in automatically fixed. And in this case, I want to keep the base. Just keep the base fixed. There's no reason to move the base, but just to show the motion here, I want this to actually be able to come up and down. So what I'll do now is I'll go ahead here and I will go ahead and do a float on this component. So now this component will just be able to move around. I will hit a Control Z here to keep it in that same area. And what I want to do is I actually want to do a distance mate between these two faces here and here to actually keep that distance so we're kind of set up the study. We can also modify the distance mate if we want to bring it closer together or further apart. So a quick way to do mates here is you can obviously either go up here to mate. You're probably familiar with doing it this way from any of your graphics classes. A way I do a lot is something that's called quick mates. You can hold down Control. It's very similar to adding a relationship in the sketch. Hold down Control and you can just select the different faces you want. And then it kind of gives you all of your different mate options here. And this will actually create a mate. So just because you're clicking this here, it's not just keeping it at that location. It is actually also creating a mate. So in this case, I'll just do a distance mate, and I'll just leave it at the default, which is whatever we literally did it in the part, which is 7 and 5/8. So we'll just leave it at that. But again, now you can go down to mates, and you can always modify that mate if you want to. Now this can still move around this way, which I don't really want. And again, I don't need to do any of this for the study. I could have just kept it fixed in the assembly and run the study the exact same way I did in the part. But again, if you want to have an assembly that maybe you have a different configuration, so maybe you have something. So let me do another quick mate here for concentric and keep it there. Let's go and save this assembly. So now obviously it's still kind of fixed again. Again, it can spin around because I didn't modify that. But you can do a configuration, let's say here, if I add a new configuration and call it maybe free. And what I can do is in that configuration, again, you may or may not have learned configurations in your graphics classes, but let me know if you have any questions. Then what I can do is I can actually suppress this mate. So that'll allow me to actually have this motion here. But then when I go back to this configuration here, it's actually fixed in that position. And let me know if anybody has any questions. This is probably a good place to ask for questions. Okay. So I'll keep it as a default here. And now let's kind of look at how to set up a assembly study. It's extremely similar to a study in like a part. Especially since we've been looking at multi-body parts for probably the last two examples. So you can kind of see it once we get in there, it's going to be very, very similar. So we go to simulation here, new study, it's very similar. Static, that's fine. And we'll just call it static one, that's fine. Okay, so now in this case, you have this parts dialog here. It is actually pulling the parts or the material from the part environment or from the part that was saved out to the assembly. And so if you need to modify this again, you can. That's all in there. So the next thing you can do is, again, connections. So when we're looking here under component interaction, you have this global interaction again, which is bonded. Again, you really don't need to do anything with that. So let's go and do our connection. Excuse me. So let's do our connection and let's do our spring. And very similar again, do the spring, flat parallel faces. And our split lines obviously came over from the parts, which is nice, or from the part environment. And again, I think I made this, was it 1,000, I think, maybe? I forget. But again, if it's different, it'll be slightly different, but you'll kind of get the same idea. So again, we'll select here, and we'll also select there. Actually, make sure, kind of made a mistake there. Make sure that these are in the separate boxes, very similar. So this looks identical pretty much to the part environment. So we have that. There's the stiffness. I don't need a preload really. I don't need a kind of a shear component to the spring constant. Again, I do not want distributed. Let's do total. So we'll do that. Okay. So we have that as well. And let's go ahead and hit accept. So again, very similar. Let's go to our fixture. So fixed geometry, we'll fix this. And we'll go into fixtures again. I'm kind of going through this a little bit fast, so please let me know if anybody has any questions. But since we really did this in the part and it's literally identical, except we're just dealing with separate parts now instead of separate bodies. But literally for the simulation part, it looks identical. So again, we'll use uncylindrical faces. We'll select that. And I will do a radial constraint of 0 millimeters. So that's going to allow that to move up and down like we did earlier. So we have that. I'll go and hit accept. Go and save real quick. Go and rebuild. And so now we have that. We need our external load. So let's do a force again. And we'll do this. We will do selected, actually not selected direction. I'll reverse the direction here. And I think we did like 50 newtons or something like that. And we'll go and hit accept here. So really quick. So one thing to kind of look at here is studies don't have to be really long to set up. So again, I wouldn't say this is a very complex study, but it's got some stuff going on here. It's not just, fixing one side and putting a force on the other and running the study, but you've got a connection. But even if you have connections and you have several different fixtures, it doesn't have to be a really long process setting up these studies. So that's just kind of something to look at. Some people kind of worry a little bit. They're like, oh, this study's gonna take me forever to set up. And obviously there are times if you have a huge assembly with a lot of parts in it, and you've got a lot of connections, or you have a lot of contacts, and maybe a global contact isn't going to work. You need maybe some to be bonded, some to be contact, and maybe you have connections between different parts, maybe you have springs, maybe you have whatever. And then it can get a little longer. But the process for setting up a study is really not that bad. Okay, so we have this, our study at this point, yeah, the study is set up. So now all we really need to do here is actually go ahead and mesh and run. Again, I'll show the mesh because I think this is the first time I was actually in an assembly. So the mesh looks very similar. Looks actually identical. I'll keep it at the default, and we'll go ahead and hit accept there, let it generate the mesh. Okay, mesh looks very similar. And again, you can also do mesh controls in an assembly. I think I talked about that last time. If you want to, create different things. I'll maybe look at that real quick. Let's go under mesh. Where are we here? If we do like a mesh control, you should be able, yeah, again, you can just select different areas here, different mesh densities, very similar to how you would, in a part. And you can do that. You can also do a per part size. You can also, one thing that's different in assembly is you can do a different mesh for an entire part. So you can select that entire part, and let's say I want this to be a little bit finer. So I only have 2 elements across here. So maybe let's do this. Maybe let's up it a little bit on that portion there and hit accept. And then again, remember when you do your mesh control, you always want to remesh. So create mesh. Again, this is the default. The mesh control is going to modify that for whatever I selected. And we'll go ahead and hit accept there. Let's see here. Did it create the mesh control? I don't think it actually created the mesh control. Let me do this. Let me okay. So let's do our mesh control. Again, let's use that on that part there. Let's crank it up a little bit. Let's hit accept. And let's see, maybe it just wasn't fine enough mesh control. So let's try doing this one more time. Create mesh and do accept. See if that makes it finer. It's still not. Let me see if I can just get rid of the mesh, maybe. Let's see here. Let's see. Let's see if we go here and try to do something. Unless it's just really, let's see, because usually the mesh control, like you saw last time, will have those little things. Oh, here are the mesh controls. Wait a second. So we actually have 2 mesh controls. So maybe the mesh control, let me go back to this first mesh control, edit it. So the mesh control did go there. Let's just go really, really fine. Let's crank that all the way up. Let's do this and let's remesh now. Maybe I just didn't crank it up high enough. So let's do create mesh and let's do accept. See if that'll do something. There we go. Okay. Yeah, so that mesh was just not fine enough. So now you can kind of see something like that, where you can use the mesh controls in an assembly. It's a really nice feature if you have certain parts that you want to kind of apply a finer mesh to, versus, and again, you could try to do this in the part, but sometimes with the assembly, when you can just go based on the different components, is a little bit easier. So a lot of times for simulation, it is a little bit easier just to create an assembly from whatever you're doing and do it that way. So we have that. Now what I'll do is let's go ahead and run the simulation. So we obviously, just before we run it, let's make sure we have everything. We have our fixture. So we have our fixed geometry here. We have our on cylindrical face there. We have our spring connector between those 2 split lines there, and for some reason that's not showing up on that side. Where are connectors? It's showing up there, just for some reason it's not showing the symbols. And sometimes with simulation, the symbols are kind of a little bit of a pain where they don't want to show up, which is fine. You can just kind of, look at it does it. Again, if there's no spring connector here, you're going to definitely get an error because there's nothing restraining this vertical portion here. Again, that is this simulation would fail without that spring connector, because again, there's nothing to stop this part from just going all the way down here. Again, you could bond these two together, or you could not, but you could do a contact and it would come all the way down here and just hit. Right now it's bonded, so technically bonded, it can still go all the way through this, because they're not touching initially. So we have that. Let's go here and let's just go and run this study. And with the finer mesh, it's going to take a little bit, probably longer to run. It's going to give me my large displacement again. I'll hit no. Again, I don't think you're seeing that message. But again, you can, the reason I'm kind of modeling these also kind of live is so you can always go back and you always remodel exactly how I have it, and kind of run your simulation on your side. So you don't really need the files to run them, which is really nice. So we have this. Again, let's go in here and let's see here. Let's edit the definition. Let's do megapascals. Let's do floating. And we've got that. So let's go here. And let's do chart options on displacement. I'll keep it as millimeters. And we'll do floating here as well. Again, floating for me is a personal preference. I prefer floating. Just for me, it's easier to read. Again, I read people's simulations all the time that have scientific. But it's a little bit of personal preference. If you prefer scientific notation, then yeah, by all means, keep it as scientific. I just find for me, it's a lot easier. It's a lot easier to, in my opinion, to make a mistake when it's a scientific notation, because you might have the same number, especially before what I'll do. Just to kind of show. So we go to the stress here and do chart options and keep it in scientific. In my opinion, it's really easy for people to not look at the scientific notation. They might just look at the value here. And now it looks like, so if your yield strength, they don't realize that the yield strength is, 2.2 times 10 to the second. So it's like, 20 something megapascals. Actually 20, let's see, 20, it'd be, it'd be 100. So yeah, it'd be like 220 megapascals. And right now we're at, 0.43 megapascals. So for me, it's a lot easier just you can just glance at it a lot easier versus with scientific notation. If you're using scientific notation or if you're looking at something in scientific notation, make sure you really pay attention to your exponents here. Otherwise, you'll end up with, you'll think that, this part has a factor of safety of, I don't know, like 2, when it actually has a factor of safety of like 200 and change. So that's something to definitely look at. That's why, for me personally, I like floating. Again, it depends if you're doing research, maybe sometimes publications may like it in scientific notation. So you can always modify it. But when I'm working in simulations, I always keep it in floating. And if I need to change it for, a paper or something, I'll definitely just, you can always go back in. You can also make a copy of the plot. So let me do this. What I'll do is I'll do chart options. I'll switch this back to floating. And so what you can do if you want to have 2 different ones, you can always just right click on the, either right click on the plot or just click on the plot, hit Control C, Control V. Actually, when you hit Control V, you have to actually click on the results folder and hit Control V, or it's not going to do that. Sometimes window shortcuts work with certain things in SolidWorks. Sometimes they don't. This is one of the cases where it's decided not to work. Just go and copy it, right? So right click copy, right click on results and hit paste. Then you have this copy of stress 1. And then what I can do here is, these are the identical plot, but I can go here, go to chart options and switch it to scientific. So if you want to have that thing where you can just take a snapshot of that result and put it in a paper or something. Now you have the scientific, but you also have the floating, kind of the floating point, which is, I find is a little bit easier working with. But again, whatever you're comfortable with and kind of what your preference is, you can kind of make it whatever you want. Okay, so we have this. Let's go and save one more time. And let me stop here. Does anybody have any questions or anything about, either the modeling, converting to an assembly, doing an assembly study, or anything like that? Okay, so this is probably a good place to stop for today. Again, kind of an overview of, connectors. So obviously there are many different connectors. You can do bolt connectors, you can do pin connectors. Today I only really went over the spring connector, but there are different ones. And as we maybe need them, I'll probably go over them like one at a time or something. But hopefully this kind of gives you guys an idea of what you're kind of looking at when you're kind of doing a more realistic study. Because again, this is a fairly realistic study of something you may encounter in real life. You have a spring that's getting compressed, you have a part that's sliding. So now you actually have some motion that's not just deflection in an actual body. You actually have motion of a component, and that body itself is deflecting as well due to the load that's applied and the stresses and everything. So yeah. So if there's no questions, then I think that's probably a good place to stop. So yeah, I'll open up one more time for questions. Okay, so yeah, hopefully that was helpful. And then yeah, so the next week we'll probably keep doing some more stuff like this. But yeah, so thank you everyone, and then yeah, you all have a good evening, and I'll see you next week.